let's keep this calculus train rolling. So I'm just going to briefly explain a definition that you'll see in your book. This is the curl of f. So what is the curl of f? Well, one way to define it is as I've written it on the board. Now, this is not the official definition according to the textbook. This is what you might call the practical definition. I'm only going to give you the practical definition, and I'm going to use it to derive the official definition. And then once I get that, I'll say, this is the definition. But don't memorize the official definition. Memorize this. I normally do not say memorize things, but memorize this. It's very short. And then we will talk about the divergence of a function at the end. Okay? So recall that the triangle, right, the triangle of f is equal to f by x, f by y, and f by z. Well, what if I erase f? If I erase f, I can just think of it as an operator, so that if it took something in, it would do that. So in other words, if I were to act on something else, like this, right, I could plug it in, right? But we could just ignore the red part. So I'm going to erase it. And this red pin is pretty light, so you may not even see it. So that's good. Okay, so these are operators. So an operator is something that operates on a function, right? And the derivative with respect to x, that's an operator. You take a function, I compute the derivative of that function with respect to x. I feed this x squared, I get 2x. Okay? So, well, if I take this, if I want to compute this, I could just treat each of those like vectors, right? According to that relationship. And we know what the cross product is, right? We did this in test 1. So let's just do it. Okay, so what is this equal to? Well, this is equal to what I just said, del by del x, del by del y, and del by del z. And then I'm going to cross it with p, q, and r. So notice that because I'm taking the cross product is only defined in 3 and I believe 7 dimensions. But we never discussed that one. No one talks about the 7-dimensional cross product. Okay, but otherwise, we don't talk about cross product in 2nd dimension or 8th dimension or 4th dimension. So when I say cross product, I mean in the 3rd dimension. Okay, hardly anyone talks about the 7-dimensional cross product. It's a real thing. I swear, it's not a joke. Okay, so let's do this. So I, j, k, del x, del y, del z. I'm just writing this as short for that, okay? That's all. Okay, now p, q, and r, and now I'm going to do the calculation, okay? So this is del y by r minus del z by q minus, right, del x by r minus del z p, and finally del x q minus del y p. So this is officially, well, we want to, I guess we could rewrite the final version. We get, let's say, del r by del y, del q by del z, del p del z minus del r del x del q del x minus del p del y. So this is the official definition of the curl of f, where f, right, where f is equal to p, q, and r. So p, q, and r might have x, y, and z in them, or whatever, right? So, for example, it could equal x, xz, y squared, and x plus y, right? So then you would take those functions, plug them into this massive equation, and do all that nonsense. And that would be the curl of f. So the curl of f, it actually has a physical interpretation, and there's an excellent little book called Div Grad Curl and All That, or something like this. It's definitely got an all that in the title. All that stuff or something. Div Grad Curl and All That Stuff. Something like that. Anyway, you can find this book online. It's probably very cheap. It's very old. It's paperback. The original is, at least. And it discusses the intuition behind all these things. It's really a book for physicists, and this is a math course. But, so because this is a math course and not a physics course, I don't really want to waste time discussing the intuition behind the curl. Now, to be perfectly honest, if you take a physics class, they're going to say, well, you should already have an intuition for why this is true, and they'll refer back to me. So I'm going to push it off to Dr. Claridge, and then Dr. Claridge can push it back onto me. And that's how we play this game. So that way we don't have to teach you. But anyway, that's life. Now, div f, this is very straightforward. This is the divergence, and it is going to be the sum of the partials, okay? The sum of the partials. Okay, so you take the first coordinate, you take the derivative of that with respect to x, plus the sum of the second derivative with respect to y, plus the sum of the third derivative with respect to z. And you add it all together, and that's the divergence. Let's do a few exercises. See you in the next video.